Hi there, Year 9s. For this example here, we've got a question for exercise 3E, question 8h. And in order to do this question, h, we're likely to use the index law number 8. Index law number 8 states that the nth root of a to the power of m is equivalent to a to the power of m on n. Now we've got 9 to the power of x is equal to 1 on the third root of 27. And one of the techniques that we're using so far to solve for exponential equations is that we do it by comparison. And what I can see is that currently you've got a base of 9 and this is a base of 27. So what we're going to do is we're going to try to change the basis to find if we can change it to something that we're familiar with. What I'm going to start off with is I'm going to keep this 9 to the power of x for now, but I'm going to focus on this nth root, the third root, because I can see it's relevant to rule number 8. So here, let's have a look. Third root of 27, remember, if it's a third root of 27, currently 27 is the a, and the power of 27 is clearly 1, so m is 1. So if I write it out, it's actually following the rule 27 to the power of 1 on 3. So that means I can rewrite the right-hand side as 1 over 27 to the power of 1 on 3. Okay? And then from here I can say, okay, well, now I've got the power, but note that this is not a fraction on the left-hand side. This is a fraction. And so we can then use rule number 7. Rule number 7 states that you can change one that isn't a fraction to a fraction by changing the power. If it's a negative power, it becomes a positive power in the denominator. So what we're doing is we're taking from this one and we're moving it back to here. So what I'm going to do is that 27 to the power of a third, according to this rule, it should be, if it's 1 on 27 to the power of a third, well, according to the rule, it should be 27 to the power of negative a third. So then I rewrite the right-hand side, and I now have 27 to the power of negative 1/3, whereas on the right-hand side, I've got 9 to the power of x. Now they're starting to look a lot more similar. However, the bases are different. Okay, so we need it to be in the same basis. But we can see that if we were to break down 9, we can rewrite 9 as 3 squared, because that's 9, and it's to the power of x, so it'll be 3 squared to the power of x. Whereas the 27, I can actually rewrite that as 3 cubed, because 3 times 3 is 9, and 9 times 3 again is 27. And remember, the power is still negative 1/3. So it's 27 to the power of negative a third, and this is 3 to the power of 2, which is 9, and on the left-hand side is to the power of x. Now we've got the same bases, right? But again, the powers aren't so matching right now that we can evaluate it. So what we're going to use now is rule number 3. Rule number 3 says a to the power of m, all to the power of n, is the same thing as saying m times n. So here I can multiply these two, and I can multiply these two, and that gives me 3 to the power of 2x is equivalent to 3 to the power of 3 times negative 1/3. And what you can see now is that simplifies to 3 to the power of 2x is equal to 3 to the power of, now 3 times a negative a third. Hopefully you realize that there's a divide 3 and there's a times 3. They're going to cancel out, or you can cross simplify them when you do the fraction. So 3 divided by 3 is 1. So you actually end up with negative 1. Okay? And so then now the bases are the same. What we can now say, if both the left-hand side equals the right-hand side, and both the bases are the same, well, then the powers must then be the same. So hence, you can then say, therefore, 2x must equal to the negative 1, because the powers must be the same, and that allows us to solve for x by dividing 2 on both sides, and then I get negative half. So you can see that I'm using quite a variety of the index laws there, but how did I know number 8 was going to come? It's anytime I see a surd, or the nth root of something, I know that likely rule number 8 is going to come in play. Okay, and when I see a fraction, I think of rule number 7, and then any brackets, I think of rule number 3. Okay?